Welcome to another episode of The Technical Interview, where we make complex tech topics easy to understand. Today, we are going to talk about three fundamental data structures: lists, trees, and graphs. Let's start the episode by going over what are data structures. Think of data structures as containers that hold and organize the data in the specific ways. This would make it easier to solve problems and consume the data. Let's start with the easiest data structure: lists. You can think of lists like people waiting in the line at the coffee shop. Each person is standing one behind the other one in a clear sequence. You know where exactly each person is in the line: first, second, third, and so on. And if you wanted to single out one of these people in the line, you can easily pick them out of the line based on their position. Lists in programming work similarly, with items arranged in specific order, making it easy to find and go over. Here, we are going to talk about three types of lists. First, arrays. Arrays are a fixed size lists where you know exactly how many items it can hold. You cannot change the size of the structure. Think of it as a line with a set number of spots. Second are array lists. These lists are similar to arrays, but unlike traditional arrays, they can grow in size. In other words, you can add or remove elements from them. Lastly, linked lists. Unlike the previous two types, which items are placed neatly in slots, in linked lists, they are connected through a series of links. It's like a scavenger hunt. Each item tells you where the next one is. Traditionally, you know only the start of the list. What's the drawback? Well, you can't just skip ahead. You have to follow the path one by one to get to a certain element. For example, if you want to get to item 12 in the list, you have to walk the list to get to that item. However, they are great for space saving and they can grow and shrink without any horrible penalties. Next, let's look at the trees. Think of a family tree where you can start with one ancestor at the top and from them branch and extend towards the children, grandchildren, and so on. Trees are all about hierarchy and relationships. And every node, or person in this case, can have multiple child nodes, but only one parent node. We are going to focus on two types of trees: binary trees and binary search trees. A binary tree is a tree which each node has up to two children, like a parent having only two kids. This structure allows for efficient searching and sorting. A real-world example of a use case for this tree is if you are organizing a tournament bracket. The binary tree helps you systematically determine winners and losers in a logical, step-by-step manner. Most people confuse a binary tree with a binary search tree. However, they are quite different. A binary search tree is similar to a binary tree, but with one condition. For any given parent, the left child is smaller and the right child is larger. For example, if the parent node is the number 9, the left node should be smaller than 9, and the right child, or the right node, should be bigger or equal to 9. Binary search trees make finding any particular node very efficient. Trees are great for organizing hierarchical data like file systems, family lineage, or even your decision-making process in a complex scenario. Lastly, we have graphs. If you have ever navigated a subway map, you have navigated a graph. Graphs represent a set of nodes or points connected by a set of edges or lines. In this example, The nodes are stations, and edges are the tunnels that connect them. Let's start by talking about directed graphs. These graphs have one-way edges. Think of them like a one-way street. The direction matters. You can only travel from one node to another in specific ways. Unlike directed graphs, undirected graphs are like regular streets, where you can go back and forth between locations. The connections between the two nodes work both ways. Graphs can also have weighted edges, where each edge has a distance or cost associated with it, much like toll roads or the time that it takes to go between two locations. Graphs are extremely powerful for modeling real-world systems like social networks or transportation routes and even communication networks. Lists, trees, and graphs are building blocks of many algorithms you'll encounter in technical interviews. Understanding these data structures and how the real-world examples and scenarios can make a huge difference when you need to solve a problem efficiently. Thanks for listening to this episode of the Technical Interview. Please share this podcast to other people who are getting started for their interviews or would like to learn more about various technology topics. Also, please leave a comment on what topics I should cover next. Also, here's a programming joke for making it this far. Why do Java programmers wear glasses? Because they cannot see sharp. Thank you. Until next time.